afternoon, and thank you for being here. So, my name is Ngoc Truong, and actually it's a bit difficult to pronounce, but it's like when you knock the door, it's like knock. So basically, I just got my bachelor degree last month at the University of Science and Technology of Hanoi in Vietnam. And during my work in here, I actually it was a part of my bachelor thesis, which done with Dr. Pascal Lee at the City Institute. And actually, it's Phobos and Deimos origins are really interesting objects because the origin of Phobos and Deimos is still in mystery, although it has been it was discovered in 1877, I believe. And there are a couple of prevailing hypotheses about the origins of Phobos and Deimos, is including the capturing small body like asteroid or volatile comets. And capturing small body would be very well to explain the irregular shape of satellite and also the low albedo and red slope spectra of Phobos Deimos. But it's really difficult to explain how Phobos and Deimos have changed their orbit from a very highly elliptical orbit into a nearly circular orbit like now. So another alternative hypothesis, which are about giant impacts, which basically Phobos and Deimos were formed by multiple evolutionary stages from the material recreated impact ejecta from one or more giant impacts on Mars. And people for giant impact is often classically believed that the Phobos and Deimos material, the orbital debris from a giant impact, are devoid of water or the material completely dry. Alright, so here's about a summary of our work. In this study, we're examining the tektite. The idea in here is that tektite terrestrial impact ejecta that is subject to intense heating and massive loss of volatile. And because of that, they might serve, we studied that in a view of as an analog material for the orbital debris resulting from giant planetary impacts. And we showed that actually tektites still contain water, even if it's really small. And the non-zero water in terrestrial tektites suggest that even in a giant impact origin hypothesis for Phobos and Deimos, the original material forming the moon are not necessarily devoid of water, or it might have contain significant water contents, about 0.01%. And because of that, a low or zero water content, it implies that a low or zero water content cannot be used to discriminate between the origin hypothesis for Phobos and Deimos. And then we're examining the spectra of Phobos and Deimos with spectra of tektite. And it showed that the UV, visible, and near-infrared spectra of Phobos Deimos suggest that the spectra of Phobos Deimos surface regolith appear to the first order that is consistent with the coarse-grained impact glass derived from Martian crustal material. Alright, so here's about the introduction about tektite, which are the natural glasses derived from impact melting of upper crustal material that then ejected into space with, oh, what the hell? That's then ejected into space before it's firmed back and quenching. And there are different various morphology form of tektite, which are the splat form, tektite, ablated. How is the laser? Top. Oh yeah. So it's a different morphology of tektite, it's splat form tektite. The ablated form tektite actually is the aerodynamically heating tektite. And the mono tektite are the layer tektite that were found in Murnong's local province in Laos. And here's about the Australasian Tektites Map. And tektite were just distributed in some limited area in the world. And there are 4 screw fields. And Australasian Tektites are actually found in areas in Southeast Asia, Vietnam, Laos, Cambodia, or in Australia. And Australasian Tektites are the largest true field in the world. And that's really excited to me to talk about Tektites actually in Vietnam. So here we review about actually is about water in Tektites. So in general, the Tektite water are much less than the volcanic glass like obsidian. And Australian Tektites are the youngest Tektite, the age about 0.7 million years, and and they span the largest true field. And because of that, Australian Tektite are the highest energy Tektite. Alright, so to measuring the water containing tektite, basically there are two methods, which are the manometric method, which we extracting water and then measuring the water vapor volume to determine the water content. And the second thing is the spectroscopy, when we determine the absorbance of tektite section and then we can derive the water contents. And it seems to be that the FTIR is more accurate and widely used method. So in here we review all of the published water content measurements for Australasian Tektite. And here's about the result. So here the result shows that all of the, even for a very extreme heating, so all of the tektite still contain water. And now we look at in more detail about the water in Australia. Actually, for the Australia tektite, here's about an experiment actually done at the wind tunnel at M. They produce the artificially ablated tektites in the wind tunnel, and it showed that for the ablated tektite is similar with the Australian. The artificially are similar to the Australian tektite. Also, not only of the same morphology and also the same internal structure. And the experiments show that Australian tektites, the tektite from Australia has experienced the exospheric suborbital trajectory, as well as the ejecta temperature could be up to 2000 degrees. And with the ejection velocity about 6.5 to 11.2 kilometers per second. I would emphasize so in here that this velocity is much larger than the Mars escape velocity that the debris from Mars could eject it. And despite all of that, a very high energy the Australian tektite by the extreme heating from impact as well as aerodynamic heating. So Australian tektite still containing water. And the water actually is quite small, but it's about 0.01 weight%. So here's just a bit of remind about the origin of Phobos and Deimos by giant impacts. And what it implies for Phobos and Deimos is that it implies that even in a giant impact origin hypothesis for the moon of Mars, so the water contents in the original material forming Phobos and Deimos is expected to be low, but it's not necessarily zero. And Australian tektites might provide an approximate estimate for the water contents in the original material forming Phobos and Deimos in that hypothesis about 0.01 weight%. So in here we also comparing the spectra of Phobos and Deimos with spectra of tektite. Here's actually the Phobos and Deimos spectra obtained by Mercury et al. In 1991. And Phobos and Deimos spectra show a rest slope spectra, also with a very low albedo. And the idea we comparing the spectra of tektite with spectra of Phobos and Deimos is that because if we expected Phobos and Deimos will form by giant impact, so the material forming Phobos and Deimos will be rich in silicates. And as is also similar with tektite, because tektite composition actually is about 80% of silicate. So here's about the result. So there are a few things that we see in here. It's that. So first of all, is about the effect of particle size effect from with the grain size, smaller grain size, experience a higher albedo. Here's about the grain size from smaller than 45 micron, and here's about the grain size from 90 micron to 1000 micron. So we experience that with smaller grain size, so the albedo will be increased. The second thing is that by different methods of sample preparation, even so affected to the albedo. Here we process the tektite grain with two different sample preparations. One is about the wet sieving, dry sieving method, which just basically filter and has a grain size. And the second thing is that after crushing, the sample was crushing, so it will be treatment with ethanol to remove the smaller grains that electrostatically bounded in the grain of tektite. And here we also have, here's about the grain size with the wet treatment method. And for Phobos and Deimos, actually the dry sieving is more realistic with the Phobos and Deimos material. And we see in here actually is that of course it's different because terrestrial tektite are terrestrial material. But what we will see in here that Phobos and Deimos spectra were similar tektite spectra has been red slope, also have a low albedo with Phobos and Deimos, and it seemed to be that the Phobos and Deimos spectra were consistent with silicate rich Phobos and Deimos spectra similar to the silicate rich and water poor material. All right, so there are a few things we need to do. Is the next step. We need to do more works on the quantity to more measurements, do more measurement of Australian tektite because two field sample have been studied. The second thing needs is that we need to, by the way, we're doing more measurement and collect more tektite sample. We need to know more about the context, the source location, curation history of own sample. And also, we need to determine also dispersion. There's a dispersion in here in water content among Indochina tektite. In here, we do not know that is a real or it's just a measurement consistency. And by the way, to do that, we also can confirm if there is a gradient decrease of the water measurement contents from monotektite to Australia, which people have been hypothesized that monotektite are often near the local impact site of the short crater. And all is just everything is just a constant. So we need to also confirm about that. And the final one is that more measurement of the tektite spectra also be needed. All right, so here's about a conclusion that in the giant impact origin hypothesis for the moons of Mars. So we should not necessarily expect them to be devoid of water. And because of our examining of tektite, so the original material so might contain some water, although it's likely that it's not a lot. And it's implied for future mission, for example, by JAXA for Mars Moon Explorers, that it would be that the low or zero water contents cannot be used to discriminate between origin hypothesis for Phobos and Deimos. So, but although we need to do more work to confirm about that, and also the Australasian Tektites might provide an approximate estimate about 0.01% for the water content in the original material from Phobos and Deimos in that hypothesis. And the final one, when we compare the spectra of Phobos and Deimos surface regoliths with spectra of tektite, it appears that to the first order, it might be consistent with coarse-grained impact glass derived from Martian crustal material. And the final one, all of that it's just a preliminary works, and we need to do more to understand better to the survival and fed water in the formation of tektite. And the final one, I just want to show a bit of my photo in the US. And here's actually, I met my advisor, the Pascal Lee, in the conference last year in Vietnam. Also that in Queen here for the Planetary Science Conference. I also hope that we could somehow having more collaboration after this conference. And final one, so thank you for coming to Queen.